talking through homework 1, all the solutions that you were looking for. So for the first problem, it was basically like, I think 2 walls mushed together and like something going through it. So the assumptions are like there's well insulated walls and that it's symmetrical. And then based on the fact that it's symmetrical, you can figure out what Q dot is, which ends up being 12.5 watts. And then from that, we also know that Q dot equals the following equation of negative Ka dt dx, and then that can be rearranged, and then you can solve for the thermal conductivity, and then do some just plug stuff in and you get an answer there. And then for question 1-72E, it's the, I think, CO2 flowing through a pipe, if that's right, something like that. No, it's steam. It's steam flowing through the pipe. Okay, so then the steam flows through this pipe. We can figure out the surface area from it, and then from that, we can figure out what the heat loss is from the equation Q dot equals H times AS times TS minus T air. And then you plug stuff in, get an answer, and then you can determine what the annual amount of heat loss is per year by basically just taking the value we got from part A and then just doing some conversions and then multiplying times 365 days and then 24 hours in a day. And then there's going to be your annual energy loss, which it asks for. So that's just some dimensional analysis, and then energy cost is also some more dimensional analysis. For question 1-78, it's talking about a spacecraft, and it's asking what the temperature, I believe, outside is. And so I drew a picture. Assumptions is that the solar radiation will always be constant, that the wall thermal properties are constant, and then you can set the heat of the solar equal to the heat of the radiation, and then plug in the respective equations, do some cancellations, and then solve for TS, which I said that wrong previously. I didn't mean of space. I meant that's of the spacecraft itself. And then the last problem, it was just looking up the values in the table and then just being able to convert them appropriately, which is what I did there.